Hello students, today I am going to start with exercise 4.3 of chapter pair of straight line of 12th standard. So see the first question. So you have to find the joint equation of pair of lines through the point is 2 minus 1 and which is parallel to the 2x square plus 3xy minus 9y square is equals to 0. So you are given the equation that is 2x square plus 3xy minus 9y square is equals to 0. So you have to solve it. So though you have to find out the factors, that is 9 2s are 18, and so the factors of 18 whose subtraction is 3. So we find the factors, that is 6 and 3. So you know the method of solving this, that is factorization method, and by solving this we'll get these two equations, that is two brackets x plus 3y and in second bracket 2x minus 3y is equals to 0. Inside the first bracket, that is x plus 3y is equals to 0 or 2x minus 3y is equals to 0. So these are the two separate equations. Now we start with the first one, that is x plus 3y. Now this is the separate equation. We're going to find out the slope, that is formula for finding the slope is minus a upon b. So here a is 1 and b is 3, so the slope is minus 1 by 3, and we have to find out the equation of the line having this slope, that is minus 1 by 3 and passing through the given point. So the given point is 2 and minus 1. For this we use the equation, that is y minus y1 is equals to m into bracket x minus x1. So we here the 2 is x1 and minus 1 is the y1. So we use here the values, that is y plus 1 is equals to minus 1 by 3, the slope is here, and x minus 2, the value of x1 is 2. And so by solving this we'll get, that is 3y plus 3 is equals to minus x plus 2. Similarly we have to solve for this second one, that is 2x minus 3y is equals to 0. Again we find the slope using the formula, that is minus a upon b. So minus 2 upon minus 3, so we'll get here 2 by 3. Again we have to find out the equation of the line having slope 2 by 3 and passing through the point 2 minus 1 using the formula, that is y minus y1, that is slope point form, is equals to m into bracket x minus x1. Again the point is same, that is 2 minus 1. Putting this value will get 3y plus 3 is equals to 2x minus 4. So we get here, that is x plus 3y plus 1 is equals to 0, and the second equation is 2x minus 3y minus 7 is equals to 0. Now we're going to find out the joint equation of these two lines. So we consider that this is u and this is v, and since you know that is the joint equation is given by the formula u into v is equals to 0, so x plus 3y plus 1 in first bracket and in second bracket this one, that is 2x minus 3y minus 7 is equals to 0. And now solving these two brackets we will get the equation, that is 2x square plus 3xy minus 9y square minus x minus 24y minus 7 is equals to 0. Just we have to find out the similar term, that is xy, and here is also xy. Next one the x terms and y terms, so we will get the final answer. And similarly you have to solve this second example from this question number 1. The method for solving the second one is same, that of the first one. Now we're going to start with the question number 2. So question number 2 is show that the equation x square plus 2xy plus 2y square plus 2x plus 2y plus 1 is equals to 0 does not represent a pair of line. So you know the condition for the equation which represent a pair of line. The condition is, that is abc plus 2fgh minus f square minus bg square minus ch square is equals to 0. But in this example we have to show that this equation does not represent a pair of lines, so we have to prove that this total equation is not equals to 0. So the given equation we have to compare with the general second degree equation in x and y, so which is nothing but the x square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. So we have to compare this given equation and this the general second degree equation. So the value of a will get here 1, 2h is equals to 2, b is equals to 2, 2g is equals to 2, 2f is equals to 2, and c is equals to 1. So 2h is equals to 2, so h is 1, here g is 1, and f is also 1. And now the given condition is that this equation does not represent a pair of lines, so this total term is not equals to 0, means we have to show that this will not equals to 0. Now putting all these value in this equation, we will get the answer is 2, which is not equals to 0, and so the given equation does not represent a pair of line. Now we start with the next example. Now see the question number 3rd. So question number 3rd is, show that the following equation represent a pair of line which is same that of the second example, and also we have to find out the acute angle between them. So again the example you have given, you have to compare it with the general second degree equation in x and y. So the procedure for finding this is same that of the second example. Again we have to compare this one, find out the value of a, h, b, g, f and c, and you have already given that this equation represent a pair of lines. So we are, you know the condition, that is a, b, c, means we are the, if the given equation represent a pair of line, then it satisfies the following condition, which is nothing but abc plus 2fgh minus f square minus bg square minus ch square is equals to 0. And now we have to put down all these values in this equation, and now your answer must be 0, because you have to set, because you are given that this equation represent a pair of lines, so by putting your answer must be a 0. So the answer is 152 minus 152, that is 0. So that answer is 0. So it satisfies the given condition, and so it represent a pair of line. And one more question I add here, that is we have to find out the acute angle theta between these two lines. Actually this question is not in your textbook, but I am going to ask you, that is you have to find out the acute angle between them. So we consider that the theta is the acute angle between these two lines. So you know the formula to find out the angle. So tan theta is equals to in mod, that is 2 root h square minus ab upon a plus b. So to the value of h square, that is value of h, see here the value of h we already find, that is minus half. So we are putting here the minus half square minus the value of a is 2. See the example, that is the value of a is 2 and the value of b is minus 3. We are putting this value here. So 2 into minus 3 upon 2 minus 3, that is a plus b. So 2 plus 1 by 4 plus 6 here, and so 2 root, by taking the LCM we get 25 upon 4. Since there is a minus sign, by solving this mod we will get 2 into 5 by 2, so the answer is 5. And so we get tan theta is equals to 5, so the value of theta is tan inverse of 5. And similarly we have to solve the question number 4, which is similar to that of the question number 3. So I am going to show this example, that is question number 4. That is equation you are given, that is 2x square plus xy minus y square plus x plus 4y minus 3 is equals to 0 represent a pair of line, and also we have to find out the acute angle between them. This example is similar to that of the question number 3rd. Now we are going to solve the question number 5. So find the separate equation of the lines represented by the following equations. We have to solve the two examples. I am going to solve first example, that is x minus 2 bracket square. Both the examples are same. Minus 3 into bracket x minus 2 y plus 1 plus 2 into bracket y plus 1 bracket square is equals to 0. So just observe the examples. See, x minus 2 is here, again it is repeated here, y plus 1 y plus 1. Same for the second one, x plus 1 y minus 2 and y minus 2. Thus I am going to show the method for the first example. You have to solve the question number 2nd. This is for your homework. Now see, just the first example, that is x minus 2 bracket square minus 3x minus 2 in second bracket y plus 1 plus 2 into bracket y plus 1 bracket square. Here the one simplest method, that is we have to consider that this first bracket x minus 2 is m and y plus 1 is n. Now putting this value with what we get, that is m square minus 3x. Instead of writing x minus 2, we have to write down m. For this we consider n plus 2n square. Now it is just like a quadratic equation, and again we have to solve it by the factorization method. So we have to find out the factors of 2 whose addition is 3. So the factors are minus 2 and minus 1. So m square minus 2mn minus 1mn plus 2n square is equals to 0. So taking common, that is m, and here also n, we get the two brackets m minus 2n, m minus n is equals to 0. Now we are going to put down the values of m and n. So what is m? It is x minus 2 and n is y plus 1. So this is very simple method. So put down these values. M is x minus 2, 2 is as it is, putting the value n, that is y plus 1. For that just put down the square brackets. M is again x minus 2 minus the value of n is y plus 1. Now open the brackets. X minus 2, 2y minus 2 in second, x minus 2 minus y and minus 1. Now solving this we get, that is x minus 2y, this minus 2 that is minus 4, x minus y minus 3 is equals to 0. So these are the two separate equations of the given line, and the same method we have to use for the second example. Okay, this is all about the today's lecture. We see the next examples in next lecture. Thank you.